Good morning, students. Hope you're all doing well. Welcome to the new topic that you'll be starting this semester, which will be on matrices. Okay, so this is the first lesson of the new topic on matrices. Now, this is probably something that none of you have worked before or done before in previous years. So it would be a completely new topic, but rest assured that it is pretty straightforward and probably one of the topics that are easier to understand compared to financial and possibly data as well. So for this unit on matrices, we'll be covering it for about 5 weeks. And these are the main things that we'll be covering. So the first part's going to be basic parts of a matrix and then also matrix arithmetic. So not necessarily arithmetic sequences or anything like that, but basically talking about things that relate to matrices and how we use them. And then part two is going to be similar to what we did with recursion, where we had a year 12 component. You're also going to have a year 12 component for matrices. So that's going to cover communication matrices, inverse matrices, solving equations, as well as transition matrices. The checklist for the questions you need to do for this chapter, which is chapter 5, it will be in your notes. So please refer to it when I ask you to do questions. Okay, let's get into it. So part 1, or chapter 5a, we're going to look into parts of a matrix. So a matrix, if you can describe it as a set of numbers, but arranged in a certain way. And now the way that the matrix or a set of numbers is arranged can have multiple different arrangements, but basically the way it's arranged can give us some information that might describe something. It could be like maybe you list out the number of sales you have in a week, or you might list out the cost for each part of a car. Okay, all of these numbers can be arranged in a certain way. So if you try to visualize what that looks like, I don't have any here, but that's what some applications or uses of matrices are. So the numbers inside of a matrix, okay, are called entries or elements. You probably see elements a lot more often, but if you see entries or elements, they refer to the same thing. It's basically the numbers inside a matrix. Matrices are composed of rows, so you're going to hear this word a lot. Rows, which are your horizontal numbers or horizontally aligned numbers. And then you've got your columns, which are the vertical numbers. Now, obviously, some of the numbers will cross over, but whenever we refer to the rows, that means you're looking at the numbers with in a horizontal alignment. And when you're looking at columns, you're looking at them from a vertical alignment. Okay, rows are numbered in order from top to bottom. In columns are numbered from left to right. So that's how you read a matrix. You read it either top to bottom or left to right. The entries of a matrix are referred to by their own row and column number. So when we ask for, or when you refer to the entry of a matrix, we're referring to this guy down here. Okay. So this here, Aij, and this will make more sense once we can look at the example down here, is referring to the number that is in matrix A. So we're going to call it matrix A, row I, so the row, and column J. Okay, so this basically what this denotes is the value in matrix Aij is whatever the number is, and I'll show you really shortly what that means. But basically, keep this in mind because you'll see this often. Although it does look a bit complicated. It's basically the name of the matrix. So you can call it A, B, C, D, whatever. And then I refers to the row and J refers to the column. Okay, so keep that in mind when we ask you to name an entry or identify an entry. Okay. Last thing is the order of a matrix. So when we talk about the order, you're just telling me the number of rows by the number of columns. Okay, so number of rows by the number of columns. So how many rows, so how many of these guys there are, by how many of these columns there are. So let's look at this example. Here you've got a matrix. We're going to call it matrix D. You can see, okay, that matrix D has an order of 8 by 4 because there are 8 rows. So there's row 1. row 2, R3, R4, R5 is there. Oh, sorry, R5 is right there. R6, R7, and R8. Okay, those are the rows. So remember, when you're looking at rows, you're reading it from left to right with the rows. Okay, and the columns are here. So that's C1, C2, there's column 3, and column 4. Okay, so when it comes to columns, go from top to bottom, top to bottom, top to bottom. Okay, so if I was to write down the order for this, there are 8 rows and 4 columns. Okay, 8 rows and 4 columns. It's hard to read, isn't it? Okay, that's what you write down if you're talking about the order. Tell me how many rows by how many columns. Your answer must look like this. Okay, the name of the matrix equals, and then tell me the rows by columns. Must look like that. Now, the other thing, so to explain this section a bit more because it was a bit confusing, D23, oh, sorry, let's not read it like that. D23, my bad, is equal to 19. Now, what this is saying is in matrix D, okay, in matrix D, row 2, column 3, so row number 2, so if you look at row number 2 and column number 3, the value of that is 19. Okay, that's what that's referring to. So in matrix D, row 2, column 3, where they intersect with one another, which is this number 19 right there, you find the number 19. Let's try another example. Let's say you've got in matrix D, the value of 7, 3, sorry, that's not right like that, D, 7, 3, so that's not saying D73, that's saying in matrix D, row 7, column 3, okay, so let's look at row number 7, column number 3, well, I accidentally picked the same number, okay, but in that case, it's 19 again. Okay, let's try another one. Let's say in matrix D, let's go with row 1, column 4. Okay, so that's not saying D14, it's saying row 1, column 4. So if we look at row number 1, column number 4, okay, the value of that is 86. Okay, so that's how we read these entries. Okay, or when you see this notation. So if it asks you to tell me how would you represent, for example, this number? Okay, number 60. That would be in matrix D, row 7, column 2. The value is 60. Okay, this one would be in matrix D, column number, what's that? Number 6, row number 4. The value is 78. Okay, that's how we read that. Cool. All right, let's move on to the next part. Okay, so let's look at this matrix. Okay, consider the following matrix. Write down the order of this matrix. Okay, order. So remember, when it comes to order, like that, you're telling me the number of rows by the number of columns. And refer back to, again, what row and columns mean. So row would be left to right. So these guys, that would be your rows. So the number of rows. And columns would be these numbers, top to bottom. Okay, so in this case, for question A, the number of row, or the order of this matrix, so you're going to write M equals, and tell me how many rows. So let's count 1, 2, 3, 4, 5. So there's 5 rows by how many columns? 1, 2, 3. So the order is 5 by 3. 5 rows, 3 columns. You'll notice as well, there are some numbers that are fractions. Just don't get confused with them. They're still numbers. Okay, but they're in the same row as and same columns as their respective brothers and sisters, if you want to call them that, or elements, sorry. B, find the sum of the elements in row 2. Now, we haven't come across this yet, but when you see the word sum, it just means add them all up. So add together. Okay, that's what that's saying. Find the sum, add it together. So what that's asking us is find the sum of the elements in row 2. So if we look at row number 2, we're looking at this row. We have to add all of the elements there. So in that case, it's going to be, let me fix that up. 0 plus -7 plus 1. So that means the sum of the elements in row 2 is going to be -6. Okay, adding them all up. If you're not good with your maths, please use your calculator for it. But that should be that. Question C. Okay, find the sum of the elements in column 3. So now we're looking at the same thing, again, adding it together. Okay, but we're looking at column 3 this time. So that means we're looking at all of these numbers. Okay, so for C, you're going to add -2 plus 1 plus -4 plus 9 plus 1. Okay, so putting all that together, it will be equal. So that'll be -1, -5 plus 9 is 4 plus 1 is 5. Okay, so adding a lot up. Again, if you're confused about it, use your calculators. I'll just double check to see if I've got them right. I'm not always right, which I definitely know. So that will become plus and minus becomes a minus. Yeah, so bear that in mind when you put in your calculator. Otherwise, just type it as you see it in your calculator, because your calculator should know what to do. But yeah, if you get confused, just use your calculator, so it's not that hard. Question D. Write down the elements, the element for M42. So remember what that's saying. So in matrix M, what is in row 4, column 2. Okay, so M, row 4, column 2. Not M42, row 4, column 2. So row number 4, so we're looking at the bottom row here. Then column, number 4 would be here, sorry. That's the 5th row. Row number 4, column number 2 would be here. So if I was to circle this, look at where they intersect. Number 0. Okay, so the value for M42 is 0. Row 4, column 2. R4 just means row 4. C2 obviously means column 2. Okay. All right. That's pretty straightforward, I think. If you have any questions, please let me know to clarify. I can do it on Teams if you like. All right. Next part. Let's look at types of matrices. Okay. So some matrices aren't, or actually not all matrices look like this. Okay. Some matrices have really basic information. For example, you might have what you call a row matrix. So a row matrix has only one row. Okay, hence why the name row matrix. Here's an example of it. Okay, it's a 2, 7, 10 in the elements, and the order of a row matrix is always going to have one row. Keep that in mind. Okay, row matrix, one row. So that means the first number, because remember that means the row by column, the first number is always going to be a 1. Column matrix, okay, is similar, but instead of row, it's going to be only one column. Okay, not one row, one column. Only one column. Here's an example of it, and you'll find as well with either of these matrices, they're either going to be really long horizontally or really long vertically, just depending on, again, if it's a row or column matrix. Column matrix, one row, and again, look at the order of it. Okay, you can have multiple rows for a column matrix, but only one column. Okay, keep that in mind. Any column matrix has only one column. Now, the other special type of matrix is your square matrix. Now, as it suggests, a square matrix looks like a square. And if you think about a square, it's got equal lengths and widths. Therefore, with a square matrix, it's an equal number of rows and columns. So the same number of rows, same number of columns, regardless of what it is. It could be, like for this example, a 2 by 2 matrix. Okay, because it's 2 rows and 2 columns. Okay, therefore, that's why you've got a 2 by 2. It could be a 3 by 3, 4 by 4, 5 by 5, 6 by 6. all of those are examples of a square matrix. Okay, so those are your three special types of matrices. Let's do some example questions here. Write down a row matrix that has 4 columns where the entries add up to 10. Now, for this, remember the elements of a row matrix, or the example that we have here. A row matrix has only one row, yeah? In this case, it's got one row and 4 columns. So it's going to be, and your row matrix will look like that. It's going to be long that way. So if I write a row matrix there to there, and it has to have 4 columns, yeah? So I've got one row and I have to have 1, 2, 3, 4 columns all together, yeah? So that means I need to have 4 numbers in here. And according to this, all of my numbers have to add up to 10. So I can pick any number I want. I can literally just go 10, 0, 0, 0. Okay, so it's one row, 4 columns. All right, 4 columns. And I have to add up to 10. I could even go, if I want, okay, 5, 0, 5, 0. That adds up to 10. I can make it 1, 2, what's that? 7, 0. Okay, or I can go 2, 2, 2, 3. No. Yes. No. 4. Yeah. Okay. As long as it adds up to 10. Okay. Any example from there, or any of those examples will be fine. Okay, so that's an example of our row matrix. 4 columns, 1 row. Okay, let's try B, a column matrix. So now it's a column matrix that has 5 rows. But remember, with the column matrix, it's going to be long top to bottom, and there's always only one column on it. So it's going to be a long matrix going vertically. And you have to have 5 rows. So you're going to have 1, 2, 3, 4, 5 numbers in there going up top to bottom. And they have to add up to 9. So again, similarly, I could just go 9, 0, 0, 0, 0. Just got to make sure you follow the rules. 5 rows. All right, 1, 2, 3, 4, 5. And it has to add up to 9. You can pick any combination of numbers that I want. Could even go 1, 2, 3, what's that? 5, 0, 4. Sorry, 6. My bad. My math is so bad. Okay, has to add up to 9. I could even go 1, 1, 1, 1, 5. That adds up to 9. Okay, as long as you've got, according to this, a row matrix with 5 rows. So remember, column matrix. Any column matrix has one long row and one long column and multiple rows. Getting my words mixed up. So, just leave it as that. 0, 2, 0, 7. There you go. Adds up to 9. Okay. Question C. Write down a square matrix with 3 rows, or each row and column sum is going to be 4. Now, this one here, again, it's 3 rows. It doesn't tell you how many columns, but because it's a square matrix, remember that it's going to have the same number of columns, because a square matrix, equal number of rows and columns. So it's a 3 by 3. Okay, so I have to have equal number of rows. So 1, 2, 3 rows. And then 1, 2, 3 columns. 1, 2, 3 rows, 1, 2, 3 columns. All right, so equal number for both. Make sure that, and according to this, each row and column sum is going to add up to 4. This is a little bit trickier, okay, but we can just use that 0, 0, 0 thing that I was using before for these previous ones, and just putting one number in each. Now what I'll do here is I'm going to put a 4 there, and I'll go 0, 0, 0, 4, 0, 0, 0, 4. And you'll find that each column and each row is always going to add up to 4, which is what we want. Okay, so if you can think of any other examples, go for it. But that's one combination that I can think of that will give you a sum of 4 for all the rows and all the columns. Okay. Last example, then you guys can start working. So we need to now understand, or here are some applications for matrices and why they could be helpful. So in this example, a number of people were surveyed about their age and their political party preference, so which they preferred as a political party. I can talk about all the information here, but I don't think I will But for now, just understand that you've got the age groups over here, and then you've got the political parties over here. So what this is saying is these are all the age groups, and these are the parties that they chose. Okay, age group, that's the party they chose. 15 and above, that's the party they chose. Okay, so question A is write this info down as a 3x2 matrix P. Okay, so what this is saying is you have to write all this information down in a 3x2 matrix and call it matrix P. So 3 is referring to the number of rows, 2 is the number of columns. So it's 3 rows, 2 columns, and we're going to call it matrix P. So firstly, let's start off by labeling this matrix P equals, and then it's going to have 3 rows and 2 columns. Give yourself a bit of space because there are some things that you need to put in this matrix. It's important to label the rows and columns of the matrix, as it does help you to understand what information there's going to be. So for example, if I was to write this, on the side here are going to be your 3 age groups. So the first one is 18 to 30. Second one is going to be 30 to 50. And the last one is 50 and above. So I just write 50 plus. And in terms of the columns, you've got either ALP or the coalition. Okay, so there's your rows, there's your columns. So we're going to transfer these numbers into our matrix. So for the first row column, or the first element here, 14. Next element, just going by the rows, it's 12, and the third one is 10. So for the second column, you've got on the first row 5, second one's 11, 13. And there is your matrix, matrix P, 3 rows, 2 columns, and it's got all the elements that we have there. Again, making sure that you write down the name for each row and each column so you know what you're working with. Okay, question B. What information is given by P21? So in matrix P, row 2, column 1, what is that saying? So let's look at it. Row number 2, which is this row, column number 1, which is that column there. Let's use another color. So row 2, sorry guys, row number 2, column number 1, my bad. Row 2, column 1. All right, so what that's saying is in row 2, column 1, it's the number 12. So what that means, so what does that actually tell us? That there are 12 people in the age between 30 and 50 who voted for the ALP. Okay, so that's what we write down. 12 people between the ages of 30 to 50 voted for the ALP. Okay, that's what that refers to. In row 2, column 1, there are 12 people between the ages of 30 to 50 that voted for ALP. All right, question C. Which entry gives the number of coalition voters aged 50 and above? Okay, coalition voters aged 50 and above. So if we're looking at coalition, okay, so it's that column. 50 and above would be this row. So that would be this number here. Okay, right there, number 13. So in question C, we would write 50 and above. We just write, remember what I did here previously. Where was it? This one. Okay, what I did with these. All you got to write is this guy here. Okay, so basically the entry. So what would you write? You'd write here in terms of the answer. So number 13, there would be in matrix P, row 3, column 2, you've got the number 13. Okay, which entry? So it's this entry. That's the entry. In matrix P, row 3, column 2. All right, question D. What information is given by the sum of row 2? So for question D, okay, so what info is given by all of the numbers in row number 2? So row number 2 would be this row here. Okay, so row number 2 would be 12 plus 11, which equals 23. So what information is that giving you? Well, that would be, in this case, the total number of voters between the ages of 30 and 50. Okay, so you would write that down. Number of voters between the ages of 30 to 50. Okay, that's what that's saying for B. 11 plus 12 plus 11. All right, and in question E, last one. What information is given by the sum of column 1? So we're looking at column 1, which is there. Okay, so if I added all that up, it'd be 14 plus 12 plus 10, which equals 36. So in terms of the sum of that, it's the sum of, or the total number of people who voted for the ALP. ALP. Okay, so that's what column 1 is saying. Cool. And that's basically it for 5A. So what I'd like you guys to do now is do the questions for chapter 5A, which are listed there. They're all in your textbooks. If you have any questions, please ask me, guys, on Teams.